All right, good morning, good afternoon to some of you. We're going to keep on going. Lesson 74 Reflections. So, I told you when we did the introduction that we would get in depth on all of these. And we should get that done before the end of the year. They're coming up in the next few lessons. This is the first one, and we will talk about reflections. Oh, no, we already did translation, so this is the second one. So, reflections. What in the world is a reflection? It is a transformation. What type of transformation? Do you remember that word? Isometry, isometric. The isometric transformation that reflects every point. In the figure over a given line. Okay, so today we're going to talk a lot about that line and how that's going to affect how we're going to do some reflections. Okay, if you're reflecting a point across a horizontal line, or a vertical line, okay? Think of those two pieces as a mirror, okay, to visualize how it's going to reflect on the other side, okay? So if we have a shape at the top that is 4 units away from this line, this point right here, this line, will be 4 units away from there. So really, we would go from this point to this point, this point to this point. What about this point at the top? Is it just 4 units away? No, it's at least 2 more, so I would go at least 2 more and go down. Again, if you've got a piece of paper, you can fold on that line, and they should be right on top of each other. We can do that with the vertical line as well. We won't ever reflect circles, but it would simply be the distance across the line. Okay, those are reflections. We also have mapping notation, which we will talk about shortly. It's not as clear as the translations. Sometimes you have to figure out what the mapping notation will be, and we'll talk about that as well. I've got some pages up here already. So we're going to take this shape. We'll call this, you know how inventive I am, we're going to call it A, B, C. And we're going to reflect across the line x equals -2. Now, one big issue, you have to know where that line is. So here we go with an instruction. Reflect triangle ABC across line x equals -2. Okay, you have to know where the line is, x equals -2. That came from lessons long ago, okay, in algebra even, okay. If x equals -2, what does y equal? Well, what if y equals 0? What does x equal? -2. What if y equaled 5? What does x equal? -2. Do you see that there's a line? X equals is the vertical line going up and down at whatever that x-intercept is. So it gives you the x-intercept. This is x equals -2. Okay? And if we want to reflect a triangle ABC across line x equals -2, I generally go to the point that's closest. Okay, you can start with any point that you want. If you don't want to start with A, start with B or C. Doesn't really matter. Okay, and I'm going to see that I'm going to move A 3 units, or A is 3 units away from line x equals -2. So A prime would be 3 units on the other side. So that would be my A prime. Okay. What about B? 1, 2, 3, 4 units away. So B prime would be 4 units. I can't count and talk at the same time. I'm sorry. B prime would be 4 units away from the line x equals -2 on the other side. So that would be my B prime. What about C? C is a long way, so C is 3, 4, 5, 6, 7 units away. Or I could say from A prime, it is 1, 2, 3, 4 units away from A prime. So I could simply count 1, 2, 3, 4. And there would be my C prime. Okay? Then I would draw my triangle, A prime, B prime, and C prime. Okay? Does that make sense? We're reflecting across a line. We could reflect across the x-axis or the y-axis. That would be okay too. What if I gave a different instruction? Let's find a color I haven't used. Different problem. Can you reflect ABC across, let's see, across the x-axis? Where is the x-axis? Well, you've only got 2 axes here. One is the x and one is the y. I forget sometimes and don't put my labels on them, which I really should. Every time. That's a good label maker. I'm not always the best label maker. Okay, this is my y-axis. This is my x-axis. So it's a horizontal line that goes through the origin. Okay, so if I have this line on the x-axis, do you know what another equation name for that line is? You could actually say that's y equals 0. That's actually the equation of the line that's the x-axis. Sorry, side note. But, see that, that's the y intercept is 0. Okay, so could I reflect triangle ABC across the x-axis? We can. I told you we were going to talk about mapping notation. Let's talk about mapping notation with this. We didn't give coordinates for any of these. Pause for just 1 second. We need some coordinates. I'm going back. Coordinates on all. Point A is 1, 2. C is 5, 2. B is 2, 5. Okay, what are the coordinates of the first triangle? A prime, B prime, C prime. A prime is now 1, 2, 3, 4, 5. Just making sure I'm counting right. -5, 2. Correct? What about B prime or C prime? It doesn't matter. So I've got -5, 6, 7, 8, 9. -9, 2. And B prime up here is -6, 5. Okay? Now, just looking at A, B, C and A prime, B prime, C prime, what didn't change when we did that reflection? What did not change? From A to A prime, what stayed the same? Yeah, the y values. We only changed x's. Did this y change? What about this one? None of the y values change. When you reflect across a vertical line, all the y values will stay the same. Do I need to write that down? Reflect across the y, across horizontal, oh my goodness, sorry, vertical line. Vertical line, the y's stay the same. Do you think in this next one, when we reflect across a horizontal line, what values would not change? No, you're right. If you reflect across a horizontal line, the x's stay the same. Okay? And we're fixing to find that out. It's going to be really neat. But we also are going to look at a little bit of mapping notation. I don't always love mapping notation for things other than the translations, but it can work. We talk about how far things are away. So if on this last one we wanted to look at from A to A prime, well, A to this line was 3 units, okay? So 3 units more, it's 6 units away, okay? So we can simply add 6 units to our x, to the opposite of our x value, okay? Does that make sense? Let me write it out. We may not do this other reflection. I'm doing a lot of stuff on here. So, the mapping notation, I told you that t stays the same for a transformation of an x, y. Okay? We are going to map it to, you have to look at your problem. Pick a point, it's 6 units away. So we're going to take our x value, we're going to find the opposite of the x value. So it would be -1. We're going left, so it would be -6. -1 minus 6, that would be negative. So it's not opposite of x. It's x minus 6. That's what it is, because we're moving to the left 6. Okay, and see how I have to think about that. I might even graph 1 and figure out how did I get there. Okay? We're moving left, so it's going to be the opposite. Okay? We're going opposite of this unit that we've added, so the -6. And then the y would stay the same. Would that work for all of them? We kind of have to check. 2 minus 6, does that give me a -6? No. See, now I have to think about that. That's why I never do the mapping notation. I thought, oh, I've got it this time. And I looked at it and I read it and it looked great to me. But they did a little bit different of a problem. And that's why I should just stick with the problems that are in the book. I'm so sorry. So just pause, just go on. Or they actually started with the one that was farthest away. It was 9 units. How many far away? 5, 6, 7. Yeah. I'm sorry. I will not ever ask you mapping notation because this is one that I don't like. Okay? I told you that I don't generally do it, so I'm going to just stop. No more mapping notation in this lesson. I don't even care that it asks, and I don't think they ask you in any of the problems that I give it to you. Okay? Forget mapping notation. Let's do the other problem. The one that we went to, yes, Miss Evans is being crazy. Let's go back to reflect ABC across the x-axis. The line y equals 0. So we're going to take A, and how far is it to the x-axis? 2 steps, 2 units away. So we're going to go 2 units down. Okay? And that will be our A prime? Do we already have an A prime graphed somewhere? It means we can't use A prime again. So this will be A double prime. 2 prime marks. Okay? So C, we're going 2 units. 2 units, that will be our C double prime. B, we are 2, 3, 4, 5 units away. So we're going to go 1, 2, 3, 4, 5 units down, and that will be our B double prime. And here's our triangle. What they will ask you for are coordinates. What are the coordinates of A double prime, B double prime, C double prime? So A is simply 1, -2. C double prime is simply 5, -2. B double prime is simply 2, comma, negative 5. We've gone down. Now this one, when we reflected across the y equals 0 line, all the x's stayed the same. See that right there? When we reflect across the horizontal line, the x's stayed the same. And the y's just became the opposites. So 2 became negative 2, 2 became negative 2, 5 became negative 5 for your y value. So all we did was add this negative. Okay? Whew, a lot of stuff on that page. Let's do another one. We'll just do one of these. Okay? What if I want to reflect this across the line, y equals 1? I need a name, so let's go ahead and name it W, X, Y, and Z. So can you reflect W, X, Y, Z across the line y equals 1? Okay, so we did an x equals and we did an x-axis. Where's the line y equals 1? What's your y-intercept? 1. Okay. If x equals anything, y equals positive 1. Okay. So this is the line y equals 1. We're going to reflect across. Oh, I know what's going to happen in your practice problems. You're going to reflect across a line that goes through the point. Maybe I'll just do that. Maybe I'm going to move. Watch this. I can move this pretty quick. I'm going to make it have half points, if it'll let me. Yeah, it will. So now let's see. Oh, I can look at here. Move all my coordinates down here. Okay? So what happens if the line we're reflecting across goes through our shape? What do you think we do? Well, if Z is below at negative 1/2, and it goes up a half, if it's below the line by a half point, guess where that line is going? It's going above at a half point. Okay? If W is at 1, 2.5, and it's 1.5 units above, I'm going to stop doing these little arc mark things. Okay, so here's my Z prime. I'm a little off on my thing. So W is 1.5 above this line, y equals 1. So I have to go 1.5 below. So I'm going 1.5 below. There's my W prime. What about X and Y? So what about Y is a half below, so it's going to go a half above. So it's going to be Y prime. X is 1.5, so I'm going to go 1.5 below. So what does that shape look like? The reflected shape is now in pink. Okay? Could you give coordinates on that? Yes, you could. Okay? So I've given you an x-axis, or you could do a y-axis, a horizontal line, a vertical line, a line that goes through my shape. What do we do with that? Okay, that's going to happen sometime. Okay, if it's below it, you reflect it up. If it's above, you reflect it below. Okay, and it's just going to be included in the shape. Okay, it's just going to be there no matter how pretty or how ugly, it's just there. Okay, one more line that we're going to reflect across. I've got one more up here. And I'm going to go ahead and give it a name and coordinates. So A, B, C, and D. A is at 0, 2. B is at 1, 1, 4. C is at negative 1, 6. D is at negative 2, 4, because it's the same as B. Okay? And now we're going to reflect A, B, C, D across the line y equals x. Y equals x is actually a very important line in math, okay? If you could look at it as y equals mx plus b. What is your b? What is your y-intercept? It's 0, right? There is no b out there, so the intercept is 0. So we're going to go through 0, 0. What is the slope? What's with x? 1. So the rise is 1, the run is 1. Okay, I'm going to keep this going both ways. It can be above or below. That is the line y equals x. So we're at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. If x is 7, y is 7. If x is negative 2, y is negative 2. That's that line. Okay? So what is special when you reflect across a line that's not just a straight horizontal line or a straight vertical line? Okay? Generally, I think this is the only line they're ever going to give you. They might give you y equals negative x. If you had y equals negative x, it's just a negative slope. Okay? We'll go that direction through the origin. Not going to do that one right now, but you could. Okay? So, y equals x. When you're reflecting across, I'm going to take point A because that's where I start with ones that are close. B is not too far away. But I'm going to look perpendicular to that line. It's going one diagonal length across, so I would go one diagonal length across. That would be my A prime. Okay? It just so happens that that coordinate is 2, 0. I'm going to write it somewhere else because I know that's going to be in the way. A is simply going to be 2, 0. Does that look like anything else? Maybe we need to do B. Let's do B, and then we'll see. So we're going from B, we're going one diagonal and then half of another. Okay? Shortest distance between 2 points is a straight line. We're also thinking this is perpendicular. Okay? So I'm going to go this half distance plus one more. And that's going to be B prime. What is that coordinate? It's 4, 1. Are you starting to see something? The x's and the y's have simply just flipped. Where A was 0, 2, A prime is 2, 0. The x becomes the y and the y becomes the x. Because this is y equals x. Okay? B was 1, 4. B prime became 4, 1. It will always happen that way. It's wonderful. We're going to use it in math for years to come, this line. Okay? Just know it's coming back. So, instead of drawing these lines like I have for A and B, C and D are kind of farther away. Could I simply try to see if I could just reflect and put the point, instead of negative 1, 6, could I go and say, what about 6, negative 1? Does that look like that could be C prime? Well, does it appear to come straight? Should they lie on the same line, ultimately? Yes, they should. And I promise they do. D is negative 2, 4. So could I go 4, negative 2 to be D prime? The x and the y simply switch values. Okay? So that we can shade in. I wonder if I can shade that in. Maybe I'll just color it. I'll color it yellow. Okay, there we go. That's our A prime, B prime, C prime, D prime. If you reflect across y equals x, the x's and y's just swap places. Okay, they just switch places every time. If you have y equals negative x, they switch places again and the x just becomes negative. Okay? That's all it is. Okay? Actually, they both become negative. They both switch signs. Okay? They do an application of a visual arts. They give you half of a shape and ask you to reflect it onto another. Okay? I think that's it. We do have a few problems for homework. I'm going to change colors beside yellow. We're going to do lesson 74. We're going to do the practice. You do need some graph paper for this practice. It's graphing several things. And we're going to do numbers 3, 4, 13, 14, and 19. Okay, just a little review. I love all of you, and I will hopefully see you soon. I will talk to you soon. Until next time, bye.